So let me do this projectile motion question, chapter 4, problem 95. This is slightly harder than some of the other projectile motion questions, mainly because reading the question, I can see that there's a change of height. So that'll kind of get rid of some of the simplifications I'm used to having with the easier standard projectile motion questions. So let me do this. Let me first start by sketching. So I have a mountain biker who's encounters a jump on a race course that sends him into the air at some angle to the horizontal. So all I really care about is there's a projectile. And I guess, biker doesn't look like a ball, but for the purpose of the question, doesn't matter. So there's some point where he's being launched at some angle theta. And I'm being asked for the initial speed, so I don't know that yet. And if we land at a horizontal distance, okay, so with this projectile motion, I'm gonna be given, and I'm drawing it below because I read that before, I'm gonna be given the horizontal distance. I guess I could label it R, but let me label it X final. That's gonna be my final position. And if I say where he started is y equals 0, then this final position is some amount of, let me call it y final, below the point. And this y final, let this y final be a negative number. So as I write my equations, I will kind of keep that in mind. This particular symbol, y sub f, will represent a negative number. And I'll, plug in the number of minus 24 when I plug in the number. And so, whether quantities are negative or positive, you can make a choice. The main thing is to be consistent, and, by consistent, I mean, remember your choices. Don't make sign errors. So all the projectile motion questions, they kind of start all the similar way. A lot of them, you will basically have to start by breaking the motion into, so I'm drawing my velocity vector, break the motion into two components of the horizontal that we're going to label X and the vertical that we're going to label Y. So I have a horizontal component here, Vx, vertical component here, Vy. And if I'm given the angle, I'll use it. And from, so, ka, I guess I'll just leave that there. Toa, I don't think we need to use it here, but, from so ka toa, one that says sine of an angle is the opposite over hypotenuse. And the other one that says cosine of an angle is the adjacent over the hypotenuse. Can kind of get a relationship between, let me call this V naught. Relationship between the initial velocity vector, the entire magnitude that we are looking for, and its x and y components. The ratio of y component to the hypotenuse is going to be sine theta. So when you go through the algebra and solve it, this will end up being the hypotenuse times sine theta. And this x component, which is adjacent, so adjacent over hypotenuse was cosine theta. To the algebra, you end up with the adjacent side being the hypotenuse times cosine theta. And when we are doing kinematics questions, this is the part where I have to remind you. Oftentimes you will see y with a sine and x with a cosine. Please don't make that automatic, because there will be other situations in the future. Maybe, the question writer is being tricky, and instead of giving you that angle theta there, they give you this angle phi here. And that kind of flips the relationship of sine and cosine. So what I would recommend is always be in the habit of drawing the triangle and identifying the angles that you are given. That way you will never make a mistake of mixing up sines and cosines. So we start by breaking my motion into x and y component. Usually I need to break like velocity component. And after I've done that, then I can write my kinematics equations. So for projectile motion, I never wrote projectile motion. You have x component of motion, which is pretty simple. Here, let's see. I think the function, I think the position as a function of time will be useful. So position as a function of time t is going to be, because you have zero acceleration in the horizontal direction, all the acceleration you have is downward, which is minus g. So x component will be just your initial position plus your initial x velocity, which will also be your x velocity for the entire motion, times time. And let me just look ahead to what we'll be doing in the end. I'm going to be interested in the final x position that I'll have at some final time t final. And the initial x position, I can make things easier on myself by setting my initial x position was 0. So this is going to be 0. So that's my x equation. That's probably all I can get out of the horizontal motion. Let me start writing down my vertical motion equations. There's usually two equations that are useful depending on the context. There's one that deals with the velocity. The y component of velocity as a function of time would be some initial y component of velocity, and then for projectile motion it's minus gt. And there's also y position as a function of time will be your initial y position plus the displacement that's attributable to the initial y velocity, so v naught y times time, and the displacement that's attributable to the acceleration with minus g. This will be minus 1/2 gt squared. And now looking ahead to the kind of information we are given, so we are given this y final, the number that I'll be plugging in, and we're not really told anything about the final y speed. So I have a sense that this equation is probably not going to be useful. So I'm just going to cross it out for now and not use it unless something forces me to. And for this y position thing, I'll say, okay, my final y height, just going to label it yf. And this is where it's important that I remember for myself that yf is going to be negative. And I don't need to put another minus sign here or anything like that. So that final y position is going to be equal to initial y position. I set that equal to 0 to make things easy for myself. Initial y velocity, I have it. And the time is going to be t final and minus 1/2 g t final squared. Yeah. So let me write down the cleaned up version of these equations. And this is the part that makes the question slightly harder than other projectile motion questions you might have seen me do. So I write down x final is equal to v naught, I guess I'll put in these expressions, v naught cosine theta, which I'm given theta, thankfully, times the t final. I have y final is equal to v naught sine theta times t final minus 1/2 g t final squared. And here it's important that this is not 0. And in terms of is this solvable, I think you can see that it's solvable because I have two equations. And when I look, I have one unknown, the initial speed I don't know, and t final I don't know, everything else is known. So, you know, two equations, two unknowns, it's solvable. But I think I'm gonna have to deal with the quadratic equation maybe. So the thing that makes me worry right now is the fact that in other questions, I had been able to cancel out a factor of time. Here I can't because this is not 0. So I have an equation that's a second order in time and I'm kind of stuck there. Let me give this a try. So whenever you have system of equations, the main approach you have is you want to systematically eliminate your unknowns. So since I'm looking for initial speed as the final quantity, that's actually the last thing I want to solve for. So that when I eventually solve for it, I'll have a number. So in this intermediate step, what I actually want to solve for right now is not final speed, which it's not initial speed, which I'll eventually want. It's the final time. That way I can eliminate it. So I have a choice of whether to solve it out of equation 1 or 2. I'm going to solve it out of the equation that's simpler. I'll solve it out of equation 1 and then I'll plug it into equation 2, and I'm gonna hope maybe I will somehow end up with an expression where I don't have to use quadratic formula. There's a slight chance that that might still happen, so I'll do that. I'm just gonna make some space for myself here to do the remainder of the algebra. I have this simplified equation, so I don't need the original equation where I came up with those. So I'm gonna take this. So I'll take equation 1 first and solve it for t final. Then the t final is my x final, which I have numerical value of, divided by v naught cosine theta. And this is where I can't say I'm gonna plug in the numbers to get me t final, because one of these is an unknown. So I gotta keep it algebraic. But this now becomes a tool, let me call it 1 prime, for me to eliminate this one unknown, t final, from my other equation. Because it's got t final in it, and once I plug this in, the one final equation I have won't have any t final in it. So I'm gonna rewrite this by plugging this in. That'll be y final is equal to, gotta keep all this, v naught sine theta. And I plug in t final, which is x final divided by, yeah, this is what I was looking ahead to. I think these two v naughts are gonna cancel, and it'll make things easier for me. Let me keep writing. So I have second term. Do I have space? Let me write it on the second line. So it's gonna be minus 1/2 g times t final again. So x final over v naught cosine theta squared. So let me do some of the simplifications I can do right now, because it makes me happy. This v naught will cancel with this v naught. And if I want, this is sine theta over cosine theta, which is this. I can rewrite this as tangent theta. It'll just make my expression look a little bit prettier. And since theta is a given parameter, this is just a number. So looking at this entire equation with 1, 2, 3 terms, I got v naught only in this one expression here, v naught. And it's gonna, let me, I guess, distribute the square so I don't make any mistakes. Distributing this square, it's gonna be x final squared divided by the v naught squared times cosine squared theta. So that's distributed. So what I need to do is solve for v naught, and let me do it by hand. So I just don't think I have enough room there. Let me just I wish I had started this on OneNote. Let me hide this for now. I'll have space here to work out the algebra cleanly, and then once I have final expression, then I'll copy it over here in this space. So I'll work out a final expression, and then I'll copy it over here. So let me just write a slightly cleaned up version of that one line of algebra. I have y final is equal to, a lot of things canceled out, and I'm left with the x final times tangent theta. And I'm checking the units to make sure their units match. That way I'm checking I didn't make any algebra mistake. Minus 1/2 g times x final squared over v naught squared cosine squared theta. Hopefully the units match. So I got this. So I think the first thing to do is I want to isolate this whole block of expression just on its own. That way I can kind of see what else do I need to do next. So I don't like this minus sign, so I'm going to move this over to the left hand side, move that over to the right hand side. After doing that one step of operation, I'll have 1/2 g x final squared over v naught squared cosine squared theta is equal to, and I have x final times tangent theta, that hasn't changed, and I have minus y final. Okay, so staring at this expression for a bit, I have v naught squared in the denominator, and I don't like that. So I'm thinking of an expression that can get me v naught on the numerator, and the operation I can think of is this. If I imagine multiplying through by v naught squared, then on the right hand side I'll have v naught squared on the numerator. On the left hand side, this will cancel that. I won't have v naught squared on the denominator anymore. Now, I can just do that, and I guess that nothing wrong with it. Once I've done it, on the right hand side, I'll basically have this times v naught squared. And I don't really want that, because I'm trying to solve for v naught squared by itself. So all the things that are not v naught squared, I don't want it. So I can combine this operation into this. I can, as I'm multiplying v naught squared, I can divide by that entire expression. X final times tangent theta minus y final. Then on the right hand side, this will cancel out, leaving me just with v naught squared. And on the left hand side, I'll have to write this out. Got some complicated expression. So let me write that out. So on the right hand side, I constructed this operation so that I'll have a v naught squared. That was the sort of entire purpose of me thinking through what I could do. On the left hand side, let me just write down the full expression without missing anything, without any mistakes. 1/2 g. I have x final squared on the numerator. X final squared. On the denominator, v naught squared canceled out. That was the whole purpose. I still have cosine squared theta. So I'll have cosine squared theta times, and it's this complicated expression, x final tangent theta minus y final. And I guess this is about the right step to kind of check the units, make sure I didn't make any mistakes. On the right hand side, I have unit of meter squared per second squared. So I'm hoping on the left hand side, I have unit of meter squared per second squared. G has unit of meter per second squared. The numerator here has unit of meter squared. Denominator here has unit of meter. So when you combine them, like one unit cancels out. I have meter squared per second squared. Units match. So it probably means I didn't make a mistake. And this is a correct expression so far. So now what I need to do to get v naught by itself is just to imagine taking a square root of the entire thing. So I will write that down on the right hand side as the final expression. And I'm kind of deliberately not doing a lot of simplification here. I could distribute in this cosine squared theta and do some trick identity things here, but I don't think it adds anything because I have theta as a number, so I can just plug in the number. This entire denominator will be a single number anyway, so I'll just leave that as it is. I'll just plug in the numbers. Let me write down my final expression for v naught. That's going to be square root of that entire block of expression. Let me write the numerator first. That's going to be g times x final squared, and then the denominator, I have that 2 times, and then cosine squared theta first, and then that parenthetical expression, x final times tangent theta minus y final, and I'm going to remember my y final is negative, so that minus y final is actually a positive number. So that's it. Again, as I said at the beginning, this is a bit more complicated projectile motion question because of the change of height. So my final expression will just look a little bit more complicated. There's no real way around it. Let me bring up my calculator so that I can plug in numbers and be done. Square root of g, that's 9.8. I'm just going to plug in all the numbers in basic SI units. And not put in the units, times x final 40 meters squared, divide by, and let me just put parentheses around the entire denominator, 2 times the cosine of the angle, 65 degrees squared, times, I'm going to start a new parenthesis for that new group of expression, x final, 40 meters times tangent of the same angle, 65 degrees, minus, I'll keep it that way, and then I'll plug in y final as a negative number, minus 24 meters. So, those two combined will become plus. Let me make sure I didn't, So that parenthesis closes that, this closes the overall thing, and then I need one more parenthesis to close that square root. And and without units, Wolfram alpha will do this quick calculation, that's probably right, 20. And yeah, so 20 meters. That's like 20.00 meter per second. I could have put in, 19.996, but either way should be graded as correct. So yeah, simple answer for question that took a lot of algebra. More than so, whenever you see height changing, that's when you should watch out. One, a lot of the kind of pre-derived formulas in the textbook won't work because those are derived for the situation where it's level height. And two, your algebra has a potential to get a little bit harder. Here, I actually got lucky because of this cancellation. I didn't have to use quadratic formula, but sometimes you'll have to use quadratic formula and you just have to brace yourself for all that algebra.